To learn the origin story of programming, look in your closet. Everything we can program computers to do is inspired by an almost innate human skill: weaving. We've been weaving for at least 7,000 years, and likely a lot longer. So let me fast forward a bit to the early 1800s. Building on earlier French inventions and the expertise of thousands of years of craftspeople, weaver and merchant Joseph-Marie Jacquard created a machine that could sit on top of an existing loom that used sets of punch cards to automatically control the warp and weft to create patterns. Even an unskilled worker could whiz through weaving intricately patterned, expensive fabric in a fraction of the time as a master weaver took before. The secret? Jacquard's machine used binary, punch or no punch, yes or no. And that inspired mathematician and inventor Charles Babbage's analytical engine, IBM's computer for NASA's Apollo mission, and that pocket-sized computer we call a smartphone, all of which still run on that basic idea. As Babbage's collaborator, the great mathematician and pioneering programmer Ada Lovelace once said, "The analytical engine weaves algebraic patterns, just as the Jacquard loom weaves flowers and leaves." Today, we might have ditched the punch cards, but turning numbers into actions with programming skills and thinking can be just as revolutionary. Hi, I'm Erica Brzozowski, this is Study Hall, and here are 5 reasons why everyone should take a programming class. It's no coincidence our early computer dreams resemble the Jacquard loom. It all goes back to the core idea Jacquard was working with, which is translating instructions into binary. Computers don't understand words, but they do understand yes or no, pulse of electricity or no pulse, ones and zeros. And in a programming course, you'll learn how to speak that computer language by writing code, which are instructions with a particular syntax that can be translated to a computer. Lines of code get combined into a program, which is like a complete instruction list that tells a computer how to complete a certain task. You might have heard of programming languages like Python or Java, which is a language we use in our Study Hall Code and Programming for Beginners course, which is excellent, and totally doesn't reference lasagna too much if you ask me. And just like you learn human languages by actually practicing them, you learn to program by actually programming. So from day one, you'll be writing lines of code and making your computer do fun little tasks like print hello world on screen, a programming classic. But then, you'll build on that first simple code and use logic, algorithms, and abstract thinking to weave more and more complex programs, while at the same time building up your ability to observe, to think, to communicate, and to understand the threads and connections that power our world. Just take a look around you at the number of ways computers intersect with our lives. We're living in the age of data and technology, where information is currency that systems run on. But without programming knowledge, these huge influences on our life are pretty opaque. However, just a little bit of programming knowledge can help the brain in your head outsmart the brain in your pocket. One programming class doesn't mean you'll be unleashing the next ChatGPT in the world, but you will be able to track how your YouTube algorithm works and why it suddenly decided to play all your ads in Spanish, or craft something even more intricate and beautiful than the world's finest brocade, a spreadsheet with formulas and dependencies galore. Once you see behind the curtain at how pieces of information are stored and related to each other, and the format for the instructions we give computers to play with it, you'll intuitively understand and even predict how something works. Think about something I bet all of us use countless times a day: Google. In some ways, the internet is like a giant database of information, and every time we use it, it's like we're panning for gold, sorting through the junk to get the preciously useful nuggets of information, and not get distracted by the fool's gold AI results and sketchy question forms twinkling at the top of the results. Trying to optimize the results is actually something we've learned to do naturally. Just think about how you search for something. Only the politest of grandmothers is typing in, "Please tell me how a loom works." You and I are slinging in "how to loom." But with a programming course, you'll be able to be even more intentional and hone your research skills. And being able to quickly sift through and analyze information and communicate precisely can set you apart from both humans and machines. We can take it a step further too. Rather than remaining at the whims of an algorithm, by recognizing the logic or how a system is looking for keywords, you'll be able to manipulate systems and even outsmart them. This can be little things like strategically curating what videos, ads, or search terms you interact with, to big things like designing tasks people can easily stick into an AI platform and hand back to you. And that will be vital moving forward, because understanding how something works gives you greater power over it. With programming, you can change the world, but it will also change you, because programming changes how you think in more ways than one, literally. Promising studies show that programming activates 5 regions of the brain, working out your most important learning center muscles, flexing your language processing skills, working memory, and problem solving. Writing code will also train you to be more detail-oriented. Like a loose thread, you'll soon learn that even the tiniest typo can derail an entire program, and it'll be up to your eagle eyes to spot it. More abstractly, a programming course shows you how to break even the most complex processes down into discrete parts. Algorithms are like very literal instructions for a computer, and they require very specific thinking in order to get the precise result you want. Like, what if you told someone to dress the turkey? Are they supposed to whip out an adorable little hat and coat? So even being able to sketch algorithms out on paper makes you a better communicator. If you're trying to craft an argument or teach a class or say write an educational YouTube script, think like a programmer. What are the pieces you need to define to establish a foundation? What are all the little tasks that make up the big task? Are there any pieces that repeat or only happen if something else happens? And this is something you'll be able to do after just one programming course. It's not like that woodworking course you sign up for when you're trying to remember who you are outside of your job. At the end, you'll actually be able to make stuff that's functional, unlike that nub of wood you whittled. Essentially, you've become unstoppable, like you've just gotten a power-up to enhance every digital tool you interact with. Suddenly, you're not limited to the basic templates when designing your website. In Excel, you can create custom formulas. Heck, with a little help from GitHub, you could even make the next Wordle. From animations to those creepy robots that do backflips, it all comes back to intricate lines of code. Combining programming with math, like linear algebra, is how we model the world around us, including what lies beyond our abilities to see. Because linear algebra lets us represent numbers with geometry and hold information far beyond the 3 dimensions we can visualize. And even if you don't build something new from scratch, a key part of programming is efficiency. Programmers are always writing little scripts that simplify or do mindless tasks for them, freeing up their time for higher level tasks or being able to learn the latest twist in fiber arts. If you don't want to mess with the construction yourself, you'll still be able to speak the same language as the people who do. So even if you won't be literally weaving all the lines of code together, you'll be able to design programs and see situations where programming is useful, and that helps get stuff made. Ultimately, programming is a creative endeavor. If you like getting your hands dirty and ending up with something tangible after putting in long hours, a programming course will be a wonderful artistic playground. If you have the soul of a poet but the mind of an engineer, programming is a space to find creative fulfillment while still working in the STEM fields. Now, we're not saying everyone should go all in on becoming a programmer. The people who say you should just learn to code do not in fact have your future career at heart. In fact, that ship has likely sailed as AI gets better at spitting out basic code. But thinking like a programmer can make you more valuable across industries. For starters, the people who won't be replaced by AI are the ones who can recognize what works and what doesn't, how to make something more elegant and efficient, and how to speak to both computers and humans. Plus, with a little coding, you can become much more efficient and essentially outsource your mind-numbing tasks in all kinds of different jobs. Like need to search through a customer list and find everyone who hasn't been contacted in the last 3 months and send them an email? Writing that script would take you way less time than sorting through thousands of names. In fact, Gen Z for Change did something very similar when they created a shortcut you can add to your phone that automatically sends out emails to your representatives. That's radical outreach. Ultimately, you can work smarter, not harder, no matter what it is you're trying to do. Still, all code needs oversight, and that can be you. Because no matter who writes it, programming is a long series of choices, which brings us to the best reason to take a programming course. The best reason to take a programming course is to find the humans behind the code. Once you write it yourself, you can't forget that every line of code, every choice of syntax, every if-else statement can be traced back to a real human person. Even AI code is trained on work done by people, and you can only make sure it really does what it's supposed to do and is the most elegant it can be if you know what you're looking at. Just like a real person was still designing all the woven designs, a real person decided how the information should be labeled and stored, and how it could be manipulated in the future, or even what was left out. And that has consequences. It yields insights, but also bakes in oppression mirroring what we value. Take the healthcare algorithms that disproportionately miscategorize people of color, or the AI algorithms that can't recognize darker skin tones, leading to misdiagnoses. Programming controls what information we're fed, which means it controls what we pay attention to and shapes our lives in powerful ways. But you might forget those flaws if you haven't been one of the people writing code behind the curtain. So it doesn't matter what programming language you choose, just get started. Like weaving, programming is a functional, essential creative craft. And just like textiles tell the story of humanity, and looking at who created them tells rich stories about values, art, culture, and technology, so does examining how programming weaves the fabric of our modern world. This episode was suggested and written by Madeline Doring, the editorial director of Study Hall. She's an avid crafter and has a long-held appreciation for math. So much so that a small child once said she should be called Mathy, which gave her the opportunity to take many programming classes that gave her skills she still draws on every day in every script. If you're interested in taking an online code and programming for beginners course for just $25 and unlocking the chance to earn college credit from ASU, check out gostudyhall.com or click on the button to learn more. And if you want to help us out, give this video a like, tell us what class you think everyone should take, and smash that subscribe button. Thanks for watching. See you next time.